What we're going to learn right now is a method of solving a system of equations known as substitution. Now we're going to look at this step by step, and we're going to start with something very simple. Okay, we're going to start off with this system of equations, and when I say system, it's a system because it consists of more than one equation. This would be equation 1, and this would be equation 2. Again, the order doesn't matter, but given the order they're stated, I'm going to label them 1 and 2 respectively. So if I want to solve a system, all I got to do is, over here where I have x equals 3, I'm going to replace the x in the first system with 3. So what happens? I have y plus 3 equals 10. And this is a familiar linear equation, which I can just solve by rearranging and solving for y, and I get y equals 7. Again, the 3 comes over, it's subtracted from 10, and it gives me 7. So to solve something like this would mean that the x and y value that satisfies both these equations would be 3, 7. And notice that the second equation doesn't have a y in it. All we know is that x has to equal 3, and that's true. In the first equation, okay, x plus y has to equal 10. Well, if I add the x and the y, the 3 and the 7, I get 10. Let's look at a similar situation now where we have y equals something. Again, I'm going to carry out the same process. I'm going to replace y with 2. So it's very similar, but instead of replacing x, I'm replacing y, and that equals 10. So what happens? I solve by first multiplying this 2 and negative 2. And next I bring the 4 over. So I get 3x equals 10 plus 4, which is 14, which means that x is equal to 14 over 3. So quite simple again. In this case, our solution is 14 over 3, which I'm not going to translate into a decimal, comma 2. So using this analogy, I want to extend this now to something a bit more complicated. Here's a system of equations where the second one is not given by just one variable. I have actually two variables. I have an x appearing here and a y appearing here. But what I'm going to do is exactly what I did in 1 and 2 above. I'm going to replace the x with an equivalent expression, y minus 2. Here's what I mean. So I have 2x, which is, I'm just copying this down, minus 7y equals 11. I'm going to replace this y with, sorry, not the y. I'm going to replace the x, my bad. I'm going to replace this x with y minus 2. So I have 2 times y minus 2, close bracket, minus 7y equals 11. Here I can just multiply the 2 in, so I have 2y minus 4 minus 7y equals 11, and then collect like terms. So here I'll get negative 5y equals 15, and if I do the math, divide both sides by negative 5, I get y is equal to negative 3. So y is equal to negative 3. Well, what's x equal to? Very simple. Take that negative 3, substitute it into this equation, equation number 2, and I'll have x equals negative 3 minus 2, which gives me negative 5. So my point of intersection is negative 5, comma, negative 3. So it's the same process we carried about in the previous two examples, except that this time my expression for the variable x is in terms of a binomial. This is known as the method of substitution.